Hello. Our model today showcases a slope on Poshan Road, which is located in the mid-levels. To best understand its measures, we must first learn about the disastrous tragedy it was involved in. The landslide on the 6th of June 1972. After a few days of heavy rainfall, the slope collapsed, bringing the soil debris down the hill, destroying the nearby cocktail court on the Copwell Road. It is known that the distinct characteristics of the slope has been the cause of this landslide. The water level in the mid-level mountains is very high. Thus, when it rains, the water level will rise further, causing the slope to be unstable. The rocks in the slope are strongly weathered and produce a thick layer of loose material on the slope, which is prone to collapse under heavy rainfall. In order to tackle these problems, the government has carried out lots of different preventive measures to prevent a second tragedy. As we looked at the exterior of the model, there are a couple of engineering works that can be easily seen. Layers of retaining walls are built to cover the site and slope which had collapsed and to provide physical support to it. Also, soil nails are built all over the slope surface to ensure the soil, providing similar effects. Behind the buildings, flexible barriers are built to trap any soil and rock debris that may slide down the slope in case of any small-scale landslides. But a slope with only two concrete covers isn't beautiful. The screening was also carried out on an engineered slope to improve the appearance of it. Some parts, though not displayed on the model, has also been transformed into residential areas. Engineering measures have greatly contributed to the rehabilitation of the slope, but they are not enough for this one. As said previously in the video, the amount of water in the mid-levels is extremely high. In detail, the problem with high water level is that it easily seeps into the pores between the soil particles and reduces the soil cohesion and shear strength. It will also make the slope materials heavier, increasing the shear stress. In order to solve this root of the landslide, the government built a special measure to control the flow of water. As seen in our model, many vertical tubes and two major horizontal tubes are attached. But what are they? They are the Sustainable Groundwater Level Regulation System implemented by the Geotechnical Engineering Office, consisting of sub-vertical drains and a pair of drainage tunnels. This system is also why we chose this slope for our presentation. The case of overflowing water in this slope is unlike others. If the water level is too high, the landslide will easily occur. But if the water level is too low, nearby buildings will easily subside. Thus, the system provides a controllable mechanism through opening and closing of these sub-vertical drains to ensure that the variation of groundwater level is in line with the design purpose. An atomic real-time groundwater monitoring system is also added for further assistance. To conclude, the slope measures on the slope of Poshan Road is very effective and they serve as an example for other rehabilitation cases. Thank you for listening on this video.